Hello, my name is Daniel Sugar. There's my signature. And today, I'm going to be talking to you about speakers. More specifically, I'm going to be talking to you about frequency response curves and how to use those to help you buy speakers that are good and that fit the purpose you want them for. So, let's draw a typical frequency response curve. We'll say it's around 90 and 20K. Okay, so the y-axis is sensitivity or sound pressure level, or in layman's terms, loudness. And the x-axis is frequency. And the typical frequency of human hearing is 0 to 20,000 hertz. But you can usually only hear down to 20 hertz. Anything below 20 really you experience as a pressure wave. You don't hear it, but you feel it. It's like a shock wave. I'm going to draw the frequency response curve of a typical full range driver. Now in most speaker systems, there are either 2 or 3 different types of drivers. The largest one, the woofer, handles the low frequencies, so from 20 to about 400. Mid-range, 400 to about 3,000. And tweeters handle 3,000, 20,000. But there are also types of drivers that have all 3 of them combined into one, and that's what I'm drawing here. So usually there's a reference line at the baseline sensitivity. That's the sensitivity that's listed on the driver manufacturer. So for a full range driver, it's usually going to look something like this. Generally pretty flat, but you're going to have some breakup modes in the higher frequencies. Okay, and on the manufacturers, they'll usually, on any decent speakers, they'll usually say with the sensitivity that it's plus or minus 3 decibels. Sound audible power is a logarithmic scale, so 3 decibels in increased volume is something around the order of 4 times the power, the audible power. So anything greater than that actually makes a very big difference. Okay. Now, let's go over the frequency response curves of different types of drivers. We just looked at a full range. Now we'll do a tweeter. Tweeters usually look something along the line of now they're flat in their area of expertise, so that's the high frequency. But as soon as you get lower, the efficiency of the driver drops off tremendously. Woofers, or mid-range, look something along the lines of this. They provide some low range efficiency, and also they provide high range efficiency as well, but it's usually very inconsistent. But their main area of expertise is in the middle. They handle the mid frequencies, mostly the human voice. And we'll go to woofers or subwoofers. Woofers usually look something like this. This being 20 hertz. Very, very steep drop off. Flat and down. And obviously these handle low frequencies, which you hear as explosions or the beat or the drum in music. Okay. Now, what does the frequency response curve of a perfect speaker system look like? And it is very simple. That's what the frequency response of a perfect speaker looks like. Completely flat. The point of a speaker is to take a you take a musical sound or some sort of signal, right? And you record that onto a computer, Apple or whatever. And the point of a speaker is to be able to reproduce the music without adding its own bias. So if this started off as a violin, it went into a digital signal onto a computer, and when you reproduce it on a perfect speaker system, it should sound exactly the same as the original instrument or sound that it was recorded on. But what you get with most speaker systems is they add their own influence to the music, as we can see here on the other curves. Maybe there's more volume in the mid-range, so you hear that through the speakers. So obviously the flatter the response curve, the better the speaker system. But as a trade-off, the flatter the response curve, usually the more costly the speakers will be. Alright, now I'm going to explain some tricks that manufacturers will usually try to sell you their speakers. The first one is just smoothing of the curve. So in my other examples, I was making them a little more simplistic, but an actual frequency response curve will look something like a lot of peaks and a lot of valleys, because making a flat curve is an extremely difficult thing. But what a lot of manufacturers will do, and they'll write it in the bottom in fine print, is 3 or even greater decibel smoothing, and basically that will take that curve and make it look like this. Right? So they take all the peaks and valleys and they smooth it, and it generally looks much more appealing, especially to those who don't even know how to read a frequency response curve. Another trick that manufacturers use is to have an extremely long x-axis, and so it takes a curve maybe looking like this, and it looks very smooth right now, but if we put that into a more normal sized axis, obviously it looks a lot different than that. And again, people who aren't familiar with frequency response curves will look at a curve like this and they'll say, oh my god, that's so much better than the curve up here. But in reality, they're the exact same thing. So, now with all this new knowledge, when you buy your next set of headphones, maybe perhaps Beats by Dre, and you see that the curve looks something like this, what that means is these speakers are going to be very bass heavy. The bass is going to stand out, and it's going to probably overpower lots of fine nuances that you get in the higher end, such as like flutes or other high frequency instruments. And so you really got to watch out for that when you're purchasing your speakers. Thanks.